So what happens when you give a seemingly simple word problem about a knitting unicorn, of all things, to 4 different teams of AI agents? Well, you'd expect them all to get the same answer, right? They didn't. And their mistakes, well, they reveal something absolutely fascinating and maybe a little bit concerning about how AI actually works.
Okay, so first things first, let's get on the same page and break down the actual problem these AIs were wrestling with.
So picture this. You've got our hero, Carla the unicorn, who's in the middle of knitting this absolutely epic 200-panel scarf. But of course, what's a good story without a villain? In this case, it's a mischievous elf who's about to make things complicated.
Okay, so here are the nuts and bolts. The scarf, it's 200 panels long. Carla's knitting speed is a very consistent 2 panels a minute. Now here's the twist. Right when she hits the 40% mark, this pesky elf shows up and undoes everything. That little act of sabotage takes the elf exactly 20 minutes. And this is the real kicker. Carla has to start all over again, right from the very beginning.
So, now it's your turn. Based on all that, what's the total time it takes Carla to finish this scarf? Seriously, feel free to pause and crunch the numbers. You got an answer in your head? Awesome. Let's see if you did better than our AI teams.
Okay, this is where things get really, really interesting. See, we didn't just ping one AI for the answer. We set up 4 totally separate teams of AI agents, and we gave each team a different kind of leadership style to guide how they work together. The results they came back with? Well, let's just say nobody saw this coming.
Just look at this. 4 teams, 4 completely different answers. We've got the laissez-faire team coming in at 140 minutes, the Democratic team way out there at 250, the autocratic team says 180, and the transformational team gives us 160. I mean, how is that even possible? It's one straightforward math problem. This is why we had to dig in and investigate what on earth was going on.
All right, to figure out who got it right, I think the best way is to first see where things went wrong. So let's start our investigation with the 2 teams that were the most off base. Because, trust me, their mistakes tell us a ton.
So on one hand, you have the laissez-faire team. They basically went down a creative rabbit hole that was completely irrelevant to the math. And then on the other hand, you've got the Democratic team. They did the opposite. They took a simple problem and just buried it in needless complexity. What's wild is that they both failed, but for reasons that feel surprisingly human. Okay, case file number 1, the laissez-faire team. Their final answer, 140 minutes. Right off the bat, they made a huge mistake by misunderstanding what restart meant. But their real downfall? They completely forgot they were supposed to be doing math, and instead started trying to solve the elf problem.
I'm not kidding. Instead of just calculating the time, they were spitballing ideas on how to deal with the elf. One of their actual suggestions was, get this, an anti-elf drone that would buzz around and make confusing noises. I mean, that's hilarious and maybe a little brilliant, but it has absolutely nothing to do with the question they were asked. They were solving a totally different problem.
All right, next up, case file number 2, the Democratic team, with their answer of 250 minutes. Now, their mistake was the polar opposite of the laissez-faire team. They didn't get distracted from the problem. They started adding brand new pieces to it. So this team just made something up. They invented this idea they called a reactive phase. They reasoned that after the elf messed things up, Carla the unicorn would be so annoyed that she'd get a sudden burst of energy and knit 15% faster. It's a really interesting idea, trying to model an emotional response, right? But it's totally made up. It wasn't in the problem. In their attempt to be super detailed and realistic, they just invented new facts and, surprise, got the answer totally wrong.
Okay, let's move on to our third team, the autocratic group. Now, these guys got so close. Their answer looks pretty believable on the surface, but it's got this one tiny little flaw that throws the whole thing off. So the autocratic team's answer was 180 minutes. And you can see why it seems plausible, right? Compared to the other answers, it feels like it's in the right neighborhood. They were super methodical, really structured in their approach, but one small misstep in their logic doomed the whole calculation.
So let's break down where they went wrong. They correctly figured out the 100 minutes for the full scarf. And they correctly added the elf's 20-minute delay. That's 120 so far. But then, they also added the 60 minutes it would have taken to knit the remaining panels from her first attempt. See the mistake? They basically double-counted part of the work, which is how they ended up at 180. All right, so after all those detours, the creative distractions, the over-engineering, the subtle math errors, we finally get to the team that actually solved it. The transformational team. You know what they did? They didn't brainstorm drones, they didn't invent new phases. They just read the problem and did the math.
Okay, let's walk through the correct logic. It's actually super simple. Step 1. The work Carla did before the elf showed up. She knit 80 panels, which took her 40 minutes. That time happened, it's on the clock. Step 2. The elf's disruption. That takes 20 minutes. Again, that time passed, it's on the clock. Now, step 3, and this is the crucial part. She has to restart from scratch. That means knitting the entire 200-panel scarf, which takes 100 minutes. So you just add it all up.
And there you have it. The correct answer is 160 minutes. It's just a simple sum of the time spent. No anti-elf drones, no imaginary psychological phases, no double counting. Just sticking to the facts of the problem.
So, okay, a fun little brain teaser about a unicorn, right? But why does any of this matter? Well, because this silly little experiment gives us a fascinating peek behind the curtain of AI problem solving. It shows us that the way we tell an AI to think, the framework, is just as critical as the problem we give it.
I mean, just look at the difference here. The winning team was dead on at 16 minutes, but the Democratic team, they were off by a whopping 90 minutes. It's crystal clear that the structure, the leadership style we gave each AI team had a massive impact on the final answer.
So what can we learn from all this? Well, there are a few big takeaways. First, AI is not a monolith. The rules you give it completely change the outcome. Second, more complex doesn't mean better. That reactive phase idea just muddied the waters. Third, creativity is great, but it has to be focused on the right problem. And finally, the best approach was the one that was resilient. The one that could handle a setback, reset, and solve the problem correctly without getting confused.
And that really gets to the heart of it. The big takeaway here is that when we're dealing with AI, it's not just about raw computing power. The how is just as important as the what. The way it's programmed to think, its process, that's everything. You can have the world's most powerful supercomputer, but it's completely useless if you point it at the wrong problem. And that really leaves us with a huge question, doesn't it? I mean, this was a silly, low-stakes puzzle about a unicorn scarf. But we're on the verge of asking AI to help us tackle humanity's biggest, messiest problems. Climate change, curing diseases, you name it. And if getting it to correctly solve a simple word problem is this tricky, it really makes you wonder, how do we make sure we're building the right kinds of AI to solve the problems that really, truly matter?